Good morning, friends. How are you? I hope all are doing good. So, in this video, I just want to share some of the questions on electromagnetic fields subject that were asked in recently conducted AP Government Polytechnic Lecturers Examination. So, yesterday for electrical engineering branch, AP Government Polytechnic Lecturers examination is conducted. So Polytechnic Lecturers examination is conducted. So in this video, I just want to share with you what are some of the questions. Please remember, these questions are the memory based questions. So I want to share with you the memory based questions on the subjects like electromagnetic fields, and on the subjects like circuits, on the subjects like control systems, measurements. I want to share with you these questions. So first of all, I just want to share with you the questions on electromagnetic fields subject, because if we see the question paper of Polytechnic Lecturers examination conducted in 2020, almost 20 to 25 questions are asked on electromagnetic field subject. So see how much weightage that this paper contains, that this subject contains in the total paper. Now I just want to solve some problems on memory based. So one question is asked like this. It is given that a function d bar is as, it is a vector function given. So 5x cube sine pi x by 2 ax bar, and it is asked to find what is the divergence of d bar at x is equal to 1. So this is the question asked like this. A vector function d bar is given and it is asked to find the divergence at x is equal to 1. As it is given in Cartesian coordinate system, see, the d bar is given in Cartesian coordinate system, we can easily apply the divergence formula for this function. So what is the divergence? It is del bar dot d bar is equal to dou by dou x ax bar plus, what is del bar first? Dou by dou y ay bar plus dou by dou z az bar. So this is del bar dot, what is d bar? D bar is this value. So 5x cube sine pi x by 2 ax bar. So ay bar dot ax bar is 0, so you don't have the differentiation with respect to y. Az bar dot ax bar is 0, you don't have the differentiation with respect to z. You have only the differentiation with respect to x, because ax bar dot ax bar is 1. So you will get dou by dou x of 5x cube sine pi x by 2. This is the divergence d bar. How can you find this value? Just to differentiate this term. So many students will make mistake by not considering the x here. Directly they will write 5 into x cube derivation as a 3x square, 15x square sine pi x by 2. But you need to consider the term inside the sign. We also got x term inside the sign. So how can you find this? First it is like u and it is like v. So du by dx. So x dou v by dou x, like that. So u dou v by dou x plus v dou u by dou x. What is u? 5x cube. Next, dou by dou x of this value. Sin pi x by 2 value is cos pi x by 2 into the differentiation of pi x by 2 is again pi by 2 plus u dv by dx over, next v du by dx. What is v? Sin pi x by 2 is v, du by dx 3 into 15, 15 means x cube differentiation is 3x square. So 3 into 5, 15 x square. So this is the value of divergence of d bar. Now by substituting x is equal to 1, we can find the divergence of d bar at x is equal to 1. So if you substitute x is equal to 1, you will get cos pi by 2 here. What is cos pi by 2 value? Cos 90 value is 0. So this entire thing is 0 at x is equal to 1. Similarly, at x is equal to 1, it will become sin pi by 2. So 1 into 15 into x value is again 1. So 15 into 1 square. So the divergence value of this function at x is equal to 1 is 15. This is the answer for this question. So it is just easy, but you should not forget this. Many students feel like, even though if you observe, even though if you do this by mistake as 3 into 5, 15 x square sin pi x by 2, and if you neglect the remaining thing, you will get the same answer. But this is the correct procedure of doing the differentiation. So in this way you can do this problem. This is one of the questions asked in the examination. We'll see another question asked in the examination. So this question looks like this. Okay. There are two charges given. In this question, there are two charges given. So Q is equal to 10 into 10 power, not two charges, only one charge given in this problem. A charge is present here, 10 into 10 power minus 10 coulombs, and you have a point A which is at a distance of 0.2 meter from the charge Q. Similarly, you have another point B which is at a distance of 0.4 meter from Q. So what we need to find is the potential difference between A and B. So VAB. So actually VAB is nothing but the potential difference between A and B. So VA minus VB. So in order to find the potential difference, actually when the charge is given, how can you find the potential? Assuming the zero reference means assuming at infinite the potential as 0. At infinite, if we assume the potential as 0, we will get the potential expression as V is equal to Q by 4 pi epsilon naught R. Okay. Now what we need to find is the potential difference between A and B. First we need to know VA value. VA value can be obtained by taking Q by 4 pi epsilon naught RA. Similarly, how can I get VB value? VB is nothing but the potential at B due to the charge Q. VA is nothing but the potential at A due to the charge Q. So Q by 4 pi epsilon naught RB. Now by finding VA and VB, by subtracting VA and VB, we will get the potential difference. Based upon the options, we need to check whether we are getting negative values or positive values. In the options, they are given as positive values. So you will have the potential at A is higher because RA is lesser. The distance from the charge Q to the point A is 0.2 and the distance of point B from the charge Q is 0.4. So the potential at A is definitely greater than the potential at B. If you find VA minus VB, it will give a positive value. It will give a positive value. So Q value now is 10 into 10 power minus 10 divided with 4 pi into. So while you are substituting epsilon in epsilon naught in the competitive examination, my suggestion is take the epsilon value as 1 by 36 pi into 10 power minus 9 because it will reduces your calculations and saves some time. So what is RA value? 0.2. Now what is this value? So 4 pi 1s, 4 pi 9s, 10 power 9, and here you get 10 power minus 1. 10 power minus 1 into 10, you will get 1, and it will go to numerator. So 9 will go to numerator, and divided by 0.2 will left. So 9 divided by 0.2 can be written as 90 divided by 2, which is 45. So this is VA value is 45 volts. Similarly, how can you find VB value? So VB value is the same charge. So 10 into 10 power minus 10 divided with 4 pi into what is epsilon naught value. So my suggestion is substitute epsilon value as 1 by 36 pi into 10 power minus 9. You have another value of epsilon naught as 8.854 into 10 power minus 12. If you take that value, even though you'll get the answer, but you need to substitute this in the calculator. So entering all the things in the calculator is a time taking process, because virtual calculator is not so much handy when compared to normal scientific calculator. So what is RB? 0.4. So 4 pi 1s, 4 pi 9s, 10 power 9s, 10 power minus 1. So you will get this with cancel 9 by 0.4. So what you will get, 90 by 4, you will get this value as 22.5 volts. As we got 90 by 2 as 45, you will get 90 by 4 as 22.5. So that what is VAB? VA minus VB. So it is equal to 45 minus 22.5 volts. So you will get finally 22.5 volts. So this is the answer for the question. So simple here, a charge is given, two different points are given which are at different locations from the charge. What we need to find is the potential difference. When a charge is given, the potential difference is to be expressed like this. There are different ways of finding the potential or potential difference. One, if you know the electric field, you can find directly by taking the integration of minus E dot dl. Even based upon that formula also, 2 or 3 questions are asked. So in this way you can solve this problem. Another some simple questions are also asked in problem, but the weightage of EMF is given as more. Okay, and here it is given in the free space, the third question. This is the third question. It is given in the free space, rho V means volume charge density is given, which is 80 microcoulomb per meter cube. Means for 1 meter cube of volume, the charge is 80 microcoulombs. This is the volume charge density given in the free space, and it is given that this exists only for the region 8 millimeter less than or less than 10 millimeter. Means this volume charge density is available from the radius 8 millimeters to 10 millimeters. In between these two radii only you have this volume charge density present. Whereas from 0 to 8 millimeters, the volume charge density is given as 0. This is the data given. What we need to find is charge, the total charge inside a sphere of radius 10 millimeter. See here, you have a sphere. This is the sphere. Okay. So let me draw it in a nice way. Okay, somewhat better. So this is the center of the sphere, and what is this? This is the radius of the sphere. What we need to find is the total charge present inside Q inside a sphere of radius. What is the radius of the sphere given? 10 millimeter. And it is also given that up to the radius from 0 to 8, for example, I am just dividing the total sphere into two different radii. This at this point r is equal to 0, and I am assuming this is 8 millimeter radius. So from 0 to 8 millimeter radius, you don't have any volume charge density. So the charge in up to this region is 0. And from 8 to 10, so here you have 8 and this is 10 millimeter. So from 8 to 10, you have a volume charge density of 80 microcoulomb per meter cube given. So what is the total charge present inside a sphere? So the total charge present inside a sphere actually is the multiplication of rho v into volume. We know that because rho v is nothing but the volume charge density. Volume charge density is nothing but the ratio of the total charge by total volume. In order to find the total charge, I just multiply volume with rho v. But I need to multiply with which volume? The volume which is contained in between these two radii, I need to multiply this with that volume. How can you find the volume in between these two regions? So you have a formula to find the volume of a spherical region. What is that? The variation in r can be written as dr. The variation in theta can be written as r d theta. So r d theta. And the variation in phi can be written as r sin theta d phi. So you will get r square sin theta. So r d theta for theta variation, r sin theta d phi for phi variation, and dr for r variation. Here for this region we need to find what is the volume. In order to find the volume of this region, what is the theta variation? Theta variation is from total, means theta is equal to 0 to pi, and phi is also total, phi is equal to 0 to pi, but r is from 8 millimeters to 10 millimeters. We need to observe this. Okay. In this way we can obtain the volume of shaded portion. This is the shaded portion which is in between 8 mm to 10 mm. Now for this integration sin theta d theta, sin theta d theta is minus cos theta within the limits of 0 to pi. You will get 2 as that value, and integration of d phi is phi within the limits of 0 to 2 pi. You will get 2 pi as that value, and you will have now r square dr. R square dr integration is r cube by 3. Is it right? Within the limits of 8 millimeter to 10 millimeter. Right? So what you will get? 2 into 2 pi, 4 pi. And if you take the millimeter cube, millimeter is 10 power minus 3 meter. So 10 power minus 3 meter whole cube, 10 power minus 9 meter cube. So you will get 4 pi into 10 power minus 9 and by 3 as common. So 4 pi by 3 into 10 power minus 9, and here you will get 10 square minus, sorry, not 10 square, 10 cube minus 8 cube. Is it right? 10 cube minus 8 cube. Is it right or not? So what you will get finally, the volume of the shaded portion is equal to 4 pi into 10 power minus 9 by 3. 10 cube will gives you 1000 minus 8 cube will gives you 512. Is it right or not? Okay. So 4 pi by 3 into 10 power minus 19, you will get 488. 488. This is the value of volume. Now how can you find the total charge? Total charge inside a sphere of radius 10 millimeter. Up to this there is no charge. Up to this you have a volume charge density, and you need to multiply this volume with this volume charge density rho v. So what is rho v? 80 microcoulomb per meter cube into 4 pi by 3 into 10 power minus 9 into 488 meter cube. So meter cube gets cancelled. So here you have 10 power minus 6, 10 power minus 19, 10 power minus 6 into 10 power minus 9, 10 power minus 15. Okay, so you will get 80 into 4 pi into 488 by 3. So just find this value and you will get the charge. So in this way I am just leaving that for you. Just do it. It is a very simple one. 80 into 4 pi into 488 by 3. That is the value which is already available in the options. But actually the charge is given in picocoulombs. Pico means you need to convert it into 10 power minus 12. So here in this way you can find the charge. It is a very simple one. Up to the radius 8 millimeter there is no charge density. From 8 millimeters to 10 millimeters you have rho. We need to find the total charge present inside the sphere. How can you find the total charge? Charge is obtained by multiplying rho v with volume. But which volume we need to take? We should not take the entire volume. We need to take the volume within this region. That is the reason why theta limits are complete limits. Phi limits are also complete limits. But R limits are from 8 millimeter to 10 millimeter. In this way you can get the charge inside the sphere. Okay, thank you very much. In the next video we will see some more questions that are asked in polytechnic lecturers examination. So if you really like this video, please share this among your friends. I request all of you to see the complete video, because if you skip the video or if you see 2 to 3 minutes, you cannot understand the entire concept. Okay, thank you very much.